Are you looking to speed up your matrix multiplication by using multiple GPUs? If so, you're in the right place. Today, we will explore how to parallelize matrix operations using two GPUs effectively. I totally understand the frustration of trying to optimize your code and not seeing the expected performance gains. You're not alone in this struggle, and many developers face similar challenges when working with GPU parallelization. Here's the specific question we're addressing today. One user wants to parallelize the expression C equals A to the power of n plus B to the power of n on two GPUs. They want to compute A to the power of n on GPU 0 and B to the power of n on GPU 1 before summing the results. Sound familiar? Let's dive into the details. So what's the issue here? In TensorFlow, this is straightforward, but with PyTorch's dynamic nature, it can get tricky. The user tried to use separate devices for A and B, but it didn't yield the expected speedup. Let's break down why that might be happening. And stick around. At the end of this video, I'll share a pro tip that can help you optimize your GPU usage even further. To begin parallelizing matrix multiplication in PyTorch, the user should first ensure that both matrices A and B are moved to their respective GPUs. This can be done by using the appropriate device context. Next, the user needs to compute A raised to the power of n on GPU 0. This is done by calling the matrix power function within the device context for GPU 0. Simultaneously, the user should compute B raised to the power of n on GPU 1. This is done in a similar manner, ensuring that the computation is performed on the correct device. After both computations are complete, the user can then transfer the result of B raised to the power of n back to GPU 0 for the final summation. This ensures that both results are on the same device for the addition. Finally, the user can sum the results of A raised to the power of n and B raised to the power of n. This can be done with a simple addition operation, and the result will be stored in C. Fun fact: the first GPUs were designed primarily for rendering graphics, but now they power everything from deep learning to cryptocurrency mining. Talk about a glow-up. Now, let's look at the answers provided by other users. An alternative approach involves using CUDA streams in PyTorch for parallel execution. This method allows operations to run simultaneously, although it may not distribute tasks across two GPUs. The user suggests creating two streams, one for each matrix operation. If you want to split the workload across devices, the user recommends moving the matrices to specific GPUs before the operations. After computing the powers, you'll need to move one matrix back to the first GPU for the addition. Here's the pro tip I promised. Always monitor your GPU usage with tools like NVIDIA's Nsight or PyTorch's built-in profiler. This will help you identify bottlenecks and optimize your code effectively. And there you have it. You should now be able to parallelize your matrix multiplication across two GPUs effectively. Remember, optimizing your code can lead to significant performance improvements. If you found this video helpful, please subscribe for more tips and tricks.